Hello and welcome to IoT North. I'm Paul Wealls. Thanks very much for joining us. We've got a great show heading on to it with Intel and talking about their software platforms, Intel Getty and OpenVINO, all around about computer vision, model, artificial intelligence, lots of exciting things. In fact, let's have a look what it's about.
In today's landscape, incorporating AI is business critical. And with the rapid pace of AI innovation, enterprises that don't keep up risk technological and competitive obsolescence. Yet AI adoption is not an easy endeavor. The complexity of integrating data science and business expertise amongst siloed teams often impedes development. As a result, many AI solutions are never deployed. A new pathway for collaboration and innovation in AI development is here. Introducing Intel Getty Platform, a new approach for AI model training that brings together data scientists and business experts to create powerful and deployable AI enterprise solutions across any industry, often in weeks, not months.
We can use this almost like an additional member of the team, trained by us and working alongside us. The remarkable thing about Intel Getty Platform is that we've been able to train it up solely using our clinical experts here at the Royal Brompton.
We replicate the assembly cell in our innovation lab, and we use the platform to develop object detection, image classification, and semantic segmentation models to monitor and validate the entire process. The platform helps us train and optimize all these models easier and faster.
Intel is empowering AI innovation. With Intel Getty Platform, AI adoption is easier than ever before, enabling enterprises to create real-world impact today.
And that's it. We've got Intel Getty today and the team around it, and we've got Paula Ramos. Hi, Paula. How are you doing?
Hi, Paul. Thank you for having me here. I'm so excited.
More than pleasure. Paula and I work together. So for full disclosure, I am the founder of IoT North Community, but I'm also the head of business development and partnerships for Intel Getty. We also have today the great Oliver Hamilton, who's been on the show before. Hi, Oliver. How are you?
Hey, I'm well, thanks. Thanks for having me on again.
Brilliant. Hey, so we're really excited to share with everybody about Intel Getty, and especially to the IoT North community. If you are live, please do say hello. We just had Joel saying hello there. So if you're on LinkedIn, YouTube, use the comments and you can chat with us, ask any questions live. We'll pop them up and we'll answer if we can, which I'm sure we'll be able to because we've got two of the best brains with us. So what is Intel Getty? Well, let me share with you. So what is Intel Getty? Well, it removes. So Intel Getty launched as Intel On. I can't believe I full part and didn't have the slides ready. I do apologize. It is live. So Intel Getty was launched by our CEO, Pat, last week with Yanis doing the demo and demonstrating the value of Getty. But what is it? What's the value of it? Right. Okay. So Intel Getty is a platform that enables anyone on enterprise teams to rapidly build CV models and accelerate business innovation with AI. So what does that really mean? Well, the problems that we help resolve is, and this is from personal experiences, you may remember when I used to work in computer vision with AD-Link, one of the barriers that we had for the adoption was actually getting models developed, computer vision models developed. And that was down to time, cost, and resource. You know, it took an awful long time to develop the models with a lot of disparity with the systems to be able to do the annotation, the data, and the model creation, which we'll touch on a little bit. There was the resource requirement as well that was quite hard to get a hold of and leverage, and they ended up being on quite long projects as well. And that was one of the biggest challenges as well, which then led to cost as well. So, when you added all those together, you could demonstrate the value of the quality and the capabilities of the products, of the models. But what happened was it headed into the POC graveyard. So if you imagine empowering anybody to create models. So, a farmer that knows the weeds in their fields, and they can annotate and around those, or, what's a good fruit, what's a bad fruit, so on and so forth. A scientist doing a research project, looking at cells and such like, which we've got great use cases on. A factory worker who knows what they're looking at, that's come along the factory belt from their experience and being able to find those faulty products along there. So on that, we created Intel Getty. And I'll hand over to Paula to tell us a little more.
Thanks, Paul. Do you want to play the video first?
I can, yeah.
Thank you.
The video.
Coffee production is a $400 billion industry, with close to 40% of costs coming from labor management. Coffee growers continually make decisions about labor management based on manual assessment during harvesting. Specialized AI can help them assess the ripeness of their coffee fruits and make data-driven decisions for how many workers will be needed for the harvest at one time. But there is a problem. Most computer vision AI models fail from being overcomplex, expensive, and not allowing for cross-collaboration, forcing teams to work in silos. What if these farmers and agronomists had access to a simpler, more cost-effective AI development interface to participate in the process? Introducing Intel Getty platform, which makes computer vision AI development more accessible by enabling teams to easily build various types of computer vision models, from detection and classification to segmentation and anomaly detection. It also enables the team to work together, the domain experts, data scientists, machine learning professionals, and also developers, to avoid the siloed teams to be more effective. In this specific use case, it makes sense to build an instant segmentation model to help farmers count their ripe fruits and predict their yield. Intel's Getty makes it easy for agronomists and data scientists to work together and identify ripe fruits starting with just 10 to 20 images, not the tens of thousands typically required to train AI models. Intel Getty is a breakthrough in the industry because you are creating computer vision workflow faster. In one single platform, you have all things together to create your prototype model. Domain experts, farmers, and agronomists can use smart annotation features for drawing boundaries and assigning labels to the fruits. The model starts training once the initial annotation required have been submitted. Once the model training is ready, the model could create the annotation by itself. Additionally, experts could use active learning and AI-assisted annotation features that help them provide feedback to the model's predictions to improve the model's quality. Following the quality criteria for each use case, Intel Getty offers a dashboard to help the team determine when the model is ready for deployment across compatible Intel hardware. The actionable insights from such a model can help coffee growers make decisions, plan their harvest, and ultimately improve their bottom line. All industries right now are using AI. Agriculture, healthcare, smart cities, manufacturing, all people need AI. With Intel Getty, you can empower your teams to solve computer vision AI across industries in a simpler, cost-effective, and more collaborative way, just like our agronomist friend.
So there we have the video. Somebody I recognize on this show is actually in that video. Paula, how much fun was that?
That was super fun. My experience mainly was in coffee. I was working 14 years for coffee growers in Colombia, and that was amazing to see this demo with Intel Getty and how simple it is to work with Intel Getty. In my personal experience, I was working 9 months creating my own annotation system, making my annotations of tens of thousands of images, and with Intel Getty, it took me just 2 days, and that was amazing.
That's really amazing.
Yes, I really want to show the people here, the audience, what kind of things we have in Intel Getty and how this is accelerating the AI development workflow. So,
excellent. Let's bring up your slides.
Thank you. So the first thing is, okay, we need to define this computer vision pipeline. We have a lot of things to do. We have data collection, annotation, training. We need to export the training model. But when we have this model ready for production, maybe we have some changes in the production line, or we have some changes with the lighting condition, or we need to change the camera, and we need to retrain the model. In many cases, we need to start from scratch. So this is also one of the things that we have with Intel Getty. So let me show you how we can incorporate different things in different kind of steps. So for data collection using Intel Getty, you need to start just with few images. You don't need to start with tens of thousands of images, because Intel Getty also provide, the user that could be domain experts, data scientists, machine learning professionals, or also developers, different kind of tools or features. So we have smart notation features that you can just draw easily the boundaries of the objects that you want to segment, that you want to classify, or do you want to find the anomaly there. And also Intel Getty provide you AI assisted annotation that the system itself is available to with the first model to create their own annotation labels. I mean, that is amazing. And also we have the active learning stuff. That is an algorithm that provide you the data set to create the annotations. With these kind of things in the data annotation, you will reduce a lot of time, because this is a real pain for developers. When you are trying to create the model by yourself, this is a real pain. So I don't know, Paul, if we have some questions in the audience, so just let me know.
Yeah, I'll pop them up as they come in. Yeah, if anybody has any questions about Getty and model development, any observations, please do share. Just simply comment in the chats on your LinkedIn, YouTube, or Twitter as we're streaming live.
Thanks, Paul. So continuing with this, so Intel Getty also provides this capability to train the model automatically. You don't need to be an expert to have the AI model ready. And if you are an expert, also you can modify the parameters and get the model that you want to have there. We have also will support different kind of architectures, and that is amazing. For when you finalize the process, when you have the model ready, you can see that in the dashboard that we have some statistics to check how the model is working with the data set that you can provide, and you can export the model. And you can export two kinds of model. You can export the native model in PyTorch, and also you can export the OpenVINO, the optimized model with OpenVINO. And that is really good because you can just run the inference with the code that you can export. You don't need to be an expert again. And this is amazing. So next step is if you need to retrain, you don't need to start from scratch, as I mentioned at the beginning. You can just retrain with the new production data that you have, and just restart and run again the model training. So for now, I just wanted to tell you that Intel Getty platform brings all things together, and the collaboration can break the bottlenecks. So we have the way to collaborate between domain experts. If they don't have any AI experience, they can work with that, with the data scientists, with the machine learning professional, and also developers. So what do you think, Paul?
You're muted.
You're muted, Paul.
Yeah, I'm on mute. Oh, classic. So yeah, can you touch just a little bit more on the optimization, and Oliver, by all means, lean in here in regards to the value there on what that helps.
So the optimization is important. So we have when you are running the model the model in production, you need to have the model, the faster and the smaller model, because maybe you have a lot of constraints in the hardware part. So this is great that we have OpenVINO integrated also in that, because you can run the inference across different Intel hardware. You don't need to have a GPU, for example. Just with a CPU is enough to run the model. And this is one of the things that we want to capture here, because when you accelerate the model and you create the optimized model for that specific hardware, and that is the magic that OpenVINO has behind of that. So I will show you that after these slides. But yes, that is the magic with the optimization part.
Excellent. So where can you put Getty? How does it work? Where does it go?
What do you mean?
So is it a SaaS platform, software platform, virtual machine?
So right now we have you can build the models with Intel Getty. We have 5G edge virtual machines on parent server and also cloud VM. So right now, you can use these three options.
So it's a virtual machine, or on premise. You can have it running in a secure environment, or you can put it in the cloud or wherever it may be with your virtual machine. As an example, on the edge of a 5G network. So great for like an industrial use case and the investments that are being made there. And then a user would access it through the web portal. Is it?
Yeah, it's a web interface, makes it super easy to get access to it. No complicated downloads or any apps or installs. Just use your regular Chrome or Firefox browser, for example, or Edge, and just log in and get started.
So does it not get a bit irritating if you annotate and say, for example, using a mouse?
If you want to use a mouse, that's fine. So some tools you can easily use a mouse for, drawing bounding boxes, for example. One of the things we do support is if you have a Microsoft Surface or an iPad, for example, modern browsers these days can leverage the input from this, so we can register stylus input. So you can actually just draw around the objects. Is fantastic when you're in segmentation, for example, which is absolutely painstaking to try and draw stuff with a mouse. But if you just got a pen, then it's so natural input. That's
really cool. And so then the deployment side, looking on the right hand side here and really leveraging and utilizing OpenVINO for the inference. Can you give us some examples of how that can run in a data center and a type of use case that would require that, and then the edge side?
So, for example, our retail example is a great point. So we have, for example, a checkout system that you have the model, but you have different kind of devices. So you can connect those devices as a client using OpenVINO model server. So and you can run the model in the server and just propagate the model to different clients using OpenVINO model server. And this is great. So you don't need to have an extra hardware. You need to have an accelerator in the edge device, just the CPU, and a proper connection to the server in that case. This is one of the examples.
Excellent. We've got a question. Sorry, go ahead.
No, I just wanted to ask you, to ask Oliver if he has more examples related data centers.
I don't have any specific examples, but this comes back to the optimization again as well. So without trying to be too Intel heavy and marketing on that side, part of the Intel hardware is we have silicon level acceleration. And on the latest Xeons, for example, they make use of Intate optimization, which is part of the OpenVINO framework. So you can convert the FP32 models, which is your default floating point 32-bit precision models, into integer 8 representation, which makes the inference much faster. And it's leveraging all those sorts of technologies on the server grade hardware that you can really benefit from those optimized models.
Excellent. We've got a question from Evan Unruh. Hi, Evan. Are the models exported as ONNX models?
So we have a PyTorch model in the native model of the platform, but easily you can use OpenVINO to convert to Onyx.
Excellent. Okay. Should we move on?
Yes, sure. So if you want to have more information about Intel Getty and you want to learn more about that, I really invite you to visit our webpage. That is getty.intel.com.
Excellent. We do have a question from Joel Budo. Thanks, Joel. How do I gain access to the Getty platform? It is under controlled release for the next couple of months with Intel. We do have the website where, if you'd like to stay updated with the platform as it's going through its evolution and more content, then we will do that. And there'll be further updates in regards to being able to request access in the not too distant future as well. By all means, if you'd like to know a little bit more, I'd love to hear about use cases personally. So by all means, do connect with me on LinkedIn, and myself or one of my team would happily have a chat with you about your use cases and your interest in how we can help with the platform as it comes to full public release in the not too distant future at all, I can assure you. On that, let me show you another video.
Artificial intelligence has huge potential in the medical field, as it is ideal for image data. And to diagnose a huge number of diseases, this requires different types of imaging, and machine learning can process this image data rapidly to get results quickly and accurately.
Primary ciliary dyskinesia is a rare inherited disorder. The cilia in our airways, these little hair-like cells that beat in a very constant and synchronized way to clear mucus out of our chest, don't work properly. For patients, they tend to have a chronic lung disease, and that tends to lead to scarring and damage, and over the longer term, respiratory failure.
To diagnose PCD, first you need a sample, and the sample is nasal brushing. That gives you access to cells, and those cells are covered with hair-like structures. Analyzing cilia manually demands that the scientist looks individually at every cilia and individually at every component of the cilia and decide if they look normal. And this is a very laborious process that can take many hours.
AI platforms can assist clinical scientists by analysing large data sets rapidly.
We can use this almost like an additional member of the team who has come into our service, and we need to train them up. We're doing the same with the Intel Getty platform, trained by us and working alongside us.
This system saves a lot of time, as it's able to process large amounts of data rapidly. And this is then able to free up time for these specialists to be able to focus on other important things.
The remarkable thing about Intel Getty platform is that we've been able to train it up solely using our clinical experts here at the Royal Brompton. We haven't had to rely on experts from artificial intelligence companies to help with that, and so it really has allowed us to train it in a way to get the very best results.
Another fantastic use case with Royal Brompton Hospital there, and it's been an absolute pleasure working with those guys. I know Oliver's worked very closely with them, and that experience has been phenomenal. It was my second customer meeting as we came out of the pandemic, and it was a well-spent morning and early afternoon with those guys. Really inspirational. So thank you for that, Royal Brompton Hospital. Paula, OpenVINO, I understand we've got some updates there.
Yeah, sure. So this is also great to share this with the community, with the IoT or North community. So I want to bring you some overview. So with this Intel Getty, we are covering, until the product, to have ready the model for production. What happened after that? What happened with that model that we have already? So you can use OpenVINO to run the deployment. That is the reason why I want to bring this idea about the OpenVINO overview. So maybe you are familiar with OpenVINO, maybe no. So OpenVINO stands for open source visual inference network optimization. But we are trying to accelerate the inference at the edge. This is one of the great things that we have with OpenVINO. So when you have this OpenVINO, accelerating your models, you will be closer to the real applications. And this is why we are talking about that artificial intelligence at every node. So we are talking that we can cover healthcare, retail, industrial, cities, and also media. And we have a great ecosystem around OpenVINO. We have thousands of companies working with OpenVINO right now, and I can bring you, these three examples. Mainly, we are working with healthcare. So Samsung Medicine create a nerve track for physicians to detect the nerve faster that the physician made this by hand. So, and this is great, just running at the edge. So BMW Group is working with the Robotron application to detect different kind of crashes or detect the people around the industry and the factory, just like a factory quality control for this kind of industrial PCs in the friendly way. So it is possible that this application could be used by people without experience in AI, and this is also good. And maybe you saw that in the keynote the previous year, Intel Innovation. They showed the FedEx robot, and that is also great. Just this little device running with the Intel hardware and also OpenVINO is good. It's a good example how we are also touching the robotic part. So why we need to use OpenVINO? And I told you that before. So we have an optimized performance, and you can run OpenVINO optimized model across different kind of Intel hardware. So we are talking about different CPUs, iGPUs, VPUs, that is Vision Process Unit, and also FPGAs. But if you have a specific model that you have a model in TensorFlow or PyTorch or Onyx, you can also use that model in that framework and just convert the model to OpenVINO and create the intermediate representation, that is the OpenVINO format. So, and you could ask me, okay, if I have Linux or Windows or Mac, OpenVINO could work with those operating systems, and I will tell you yes. So we have the support for this kind of operating system. So we are supporting Linux, Windows, and also Mac. So in the developer journey, we have different tastes. We have the build part, we have the optimize part, and also we have the deploy part. We saw that OpenVINO is touching the deployment, but also we can optimize, and also we can build or touch some things related with the building in the models with OpenVINO. And I want to show you how. So we have, do we have some questions, Paul?
Nothing's come through just yet. No. If anybody has any questions, please do put them in comments and we'll answer them live.
Awesome. Thank you. So I invite you to take a look of the installation process that we have with OpenVINO. So you can just put in Google OpenVINO toolkit and you can see the organization that we have in GitHub. And I also invite you to go directly to OpenVINO notebooks that we have a lot of tutorials, and you can take a look of the things that I'm talking right now. You can see some examples, and you can think the things, you can make the things by yourself. So continue with this deck. I want to show you, the developer journey. So how we can scale your AI solution with Intel. So we have the build part that, as I told you, if you have your framework, you have your model, you can use that model and just convert to OpenVINO format. But also, we can provide you a lot of models. So we have different kind of models in the Open Model Zoo. We have more than 270 models that we have the OpenVINO format there. Also, we have different kind of frameworks. And also, you can find demos to test your ideas. If you want to create something, we want to go just more than that, you can use the OpenVINO training extensions. If you have your own data set, if you have your annotations, you can use the OpenVINO training extension and use the templates of the models that also we provide you. And the last one, but not the less important, is the Anomaly. Anomaly is a great library that is possible to use in industrial cases. When you have a lot of normal data, but you don't have a lot of defects. So for the optimized part, so in the optimization, we have three main tools that we have: the model optimizer, we have the post-training optimization, and we have the neural network compression framework that I will show you right now. What is the meaning of that? For the deployment part, I told you when we were talking about Intel Getty, we have the open model server. And also, you can run and deploy the OpenVINO model in different Intel hardware. So, continue with the optimization tools. We have these three tools that are so important, and I want to show you what is the difference in between these tools and when you need to use these kind of tools. So, the first tool is the model optimizer. So, in the model optimizer, you can convert your model, the model that you have in your choice framework, to the intermediate representation format, that is the OpenVINO format. We are not changing the we are not changing in that case the accuracy of the model. We are keeping the accuracy of the model. You can reduce the size of the model because we are making some optimization related with linear operation fusing, stride optimizations, and we are grouping some convolution layers. In that case, you can see that you can see the size of the model is decreasing a little bit, and also you can change the precision of the model. If you have, for example, FP32, you can have the FP16. But for the model optimizer, this is not a quantization tool. It's just optimizing the size of the model. And as I told you, you don't see any accuracy drop using the model optimizer. So the next one is the post-training optimization tool. In this case, we are running the quantization, and as a result, we have the integer 8 format in this case. As an input for this tool, we need the intermediate representation format, that is the OpenVINO format, in FP32. So we can use two algorithms, that is default quantization or accuracy-aware quantization. So you can stop the quantization when your accuracy is dropping. Or before the accuracy is dropping, you can stop the quantization. And this is also great. In this case, you need to have an unannotated data just to validate the quantization if you are using the accuracy-aware quantization. So the next one is the latest optimization tool that OpenVINO has is the neural network compression framework. So in this case, if you need a smaller and faster model, I mean, you need a lot of improvements, and you don't have this result with model optimizer or with the post-training optimization tool, you need to use this tool. You don't need to be an expert to quantize. In this case, you can use different kind of algorithms, but the most important thing here is that you need to have the training pipeline. You need to have the training pipeline in TensorFlow or in PyTorch. And using the NNCF, you can quantize your model aware training. And we have a lot of examples and documentation, and I invite you to connect with these QR codes. You can scan the QR codes and see what kind of documentation we have. And it's pretty well documented, so I invite you to see that. And also, I invite you to visit the OpenVINO notebooks repository, where you can also find some examples with NNCF, model optimizer, and post-training optimization tool. You can optimize the things using software, these kind of libraries, but also with the devices that you could use. So we have two ways, hardware and software, to optimize. So I'm just talking about 3 tools for software as libraries that we could provide in OpenVINO, but also you could see how you can optimize with hardware. In this case, and this is magic, with OpenVINO format, intermediate representation, we can compile the model and put the model in different kind of hardware. So what is the meaning of that? You can run the inference in the CPU, that is just running in your laptop, and this is great. Also, I mean, obviously laptop with Intel CPU. You can also use the iGPU that is integrated in your Intel laptop. You can use the Meetup, that is the VPU, the neural computer stick. And this is great because if you want to try something using a low-cost system, for example, Raspberry Pis, you can also use the neural, the Meetup, the Movidius, the VPU that we have. And we have also, different kind of combinations of how you can combine the performance, the hardware to improve your performance. So we have, for example, Hetero. What is the meaning of Hetero? So you can split your graph in 2 or more parts and schedule that. And that is great because some operation could be faster in the GPU, could be faster in the CPU, and you can do that with Hetero. Another thing, you can use multi where with multi you can copy the model across different devices that you have in your computer or your device. In that case, you will be able to process more frames per second, and this is also great. But the next one, I'm super excited with that one, because you don't need to think about what kind of things I need to do or how I need to set up my system. What is the best thing? So you can just keep this like an auto, and auto will select or choose what is the best combination of the devices. And you also need to say what kind of things you want to do. You want to hint throughput, or you want to hit latency, and that's it. So in auto device plug the devices that will create better performance for your model. I don't know if we have some questions on. We have just with this. We have the model optimization tool. I mean the optimization tools. Paul.
I'm back with audio. We've got a question from Evan. Are you going to use Getty to add more use cases to the model zoo? I'm trying to unmute Oliver to see if he's got anything to say. Oliver, you have to unmute yourself.
Yeah, I'll mute now. So probably not the public model zoo, because Getty is designed to be used by the consumer, the end user, whether it's tier 1, tier 2, tier 3, whatever that it rolls out to in the end. So these models will be highly customized to each use case. So you can start to build out your own personal model zoo for each customer, really.
Excellent, thank you. If anybody else has any questions, please just pop them into the comments in YouTube, LinkedIn. I don't think Twitter's shown through tonight. I think there's a bit of a glitch with Twitter again this month. Do apologize about that. But yeah, if you have got any questions, please do drop them in the chat, and we'll respond to them live.
So with that, I think that I will cover my last part. And so in that case, I really want to tell you how you can build models using OpenVINO. So basically, it's just reusing the models that we can provide you with the Open Model Zoo. So you have this option. So we have more than 270 models that are available. So you can see different kind of things. You can see object detection one, so human pose estimation, and also you have a great examples. For example, this is a great examples, by the way. This is my son and I. Just I'm running the human action recognition. And this is a great example, and also you can see that in the OpenVINO notebooks repository. I love to make scuba diving, by the way, and spend some time with my family in doing this kind of nerdy things. So, and more stuff coming. For example, how you can convert your camera in a depth camera. You don't need to have a depth camera to see this. Just running the model. And also the character recognition, so also the understandable part of that. So you can see these kind of things. For the next one, so we have the OTE, that is the OpenVINO training extensions. And this is great if you are trying to create, computer vision models, and we provide this is a transfer learning tool that you can use, and we have. This OpenVINO training extension is a computer vision framework that is covering different kind of computer vision tasks, semantic segmentation, object counting, image classification, anomaly detection, and object detection. I just have here an example, and we have an SDK in a command line. And in this example, let me see, in this example, I just want to show you how these OpenVINO training extensions are working. So we need to import the SDK in the command line functionalities, and you can select what is the template that you need to use for your computer vision task. So in this case, for example, I wanted to create a checkout algorithm model, and I wanted to select SSD model in the OpenVINO training extensions. And then I just selecting that, you can just load a YAM file, the template, and you can set up the template. You can set up all parameters that you have, the hyperparameter data, You can just reassign the batch size, the learning rate, so you can modify all of those things. And you can create the task. You can create the tasks for training, for evaluation, validation, and evaluation. And it could take some time, so you need to have more hardware to that. So I also invite you to visit and find OpenVINO training extensions in Google, and you can see how this is working. At the end, you can export the model. And you can run the model using this OT. You don't need to install anything else, just the OT training extensions, and you can see how the model is running. And I think that maybe Oliver will show something related with OTE also. And this is great. So the last thing that I want to show you is Anomaly. So Anomaly is a great library. It's more focused in factory data sets that you will see that every single time that when you try to create models for the industry, you have a lot of goods and you don't have a lot of defect information. So Anomaly is unsupervised library that you can work with this no defect. If you have a lot, you can work with that and defect. It's more related with the manufacturing, more in the industry, that you have the same scenario and the system could detect, classify, and segment the anomaly, where the abnormalities are in the images. So I also invite you to visit the repository. That is a pretty well documented repository, and you can install that and run this. In my personal experience, that was amazing. I just needed to spend 1 or 2 minutes making the training, and I have that ready for deployment. I will show you how. I just want to jump this. I don't want to show this. So in my example, for example, I have a simulation of the production line with defects. So I have boxes, the cubes, normal cubes and cubes with holes or boxes with holes. And as you can see here, I have the heat map and the anomaly is detected. So in this case, those pieces were normal, and that you can see here the abnormalities. So that was great, because as I told you, just in 1 or 2 minutes, you will have your model. I was testing this with 5 images, and that was really cool. And the end-to-end, the end-to-end part is this video. You can see how the robot is detecting the box. If the box has abnormalities, put the box out of the conveyor belt. If the box is good, so put the box over the conveyor belt. And this is running just with my laptop, so I don't need to have an extra hardware. So also, with OpenVINO, also working behind the scenes on this. And I think that this is a great example, and the things that we need to see more frequently apply in the industry, because we need to bridge the gap in between the users, real use cases, and the technology. So, Paul, this is all the things that I have. I just want to invite the people, to connect with me. If you have more questions about Intel Getty and OpenVINO, I'm more than happy to answer those questions, and also visit our repository, OpenVINO Notebooks.
Excellent. Thank you, Paula. That's right. I'm trying to turn Oliver off mute, but I can't. But great. Thank you very much for that. It was a great update. Really appreciate it. If you've got any questions on OpenVINO, I can't even say it. We were laughing.
Anomaly.
Yeah, that's the one. I can't even say it. Yes, we've got a question here from Sarah. Can we use our own annotated data and get it trained in Getty platform? Handing to you, Oliver.
Oh, sorry. Yeah. Sorry. Waiting for someone to answer. Yeah, absolutely. The Getty platform is designed so you can use your own data to train on and train models for your own data. As Paul mentioned at the beginning, we are doing a bit of a phased stage rollout, so it's not quite publicly available yet. But yeah, do keep tuning into the website to find out more information as that comes available.
Excellent, thank you. Yeah, by all means, we'll keep you updated on here. Go to the website, which is getty.intel.com. We have it here. Check it out. You can register interest for the marketing team to keep you abreast of new content and new updates as we move through very quickly over the coming months for getting access. Our big drive is to get this into the hands of everybody over the coming months. Just before we jump on to Oliver and his birds, and a good fun project that if you haven't followed it on Twitter, then check out Birdbox Bot. Let me just take that link off. Jump on Twitter, check that out. Just before that, we've got another great use case with a company called Bravant that has been part of an early program to get access to Getty. Funny enough, some of you may remember one of the faces on here, Sergio, who won a hackathon that I ran a couple of years ago with Intel. And here's
the key challenge the computer vision experts face every day is the training required to train new models, and also the computer power you need to put it to work in production environments. My name is Sergio Velasco, and I'm the Edge Computing and IoT Technical Lead here at Bravant. When it comes to designing effective machine learning solutions, the development process needs to be faster and adaptable, which is where Intel's computer vision AI platform becomes essential.
My name is Henk Paris and I'm the Director of Operations here at Bravant. Bravant is an IT consulting company helping our clients with their digital transformation. One of the biggest steps in the digital transformation process is the use of artificial intelligence. So in the last 2 to 3 years, we're doing a lot of proof of concept to see how AI solutions like Intel's computer vision AI platform can help our clients. When looking at a specific sector like the manufacturing industry, in one of our clients, the operators have to assemble a product consisting of many parts and doing this as fast as possible. They clearly needed an automated method to support the quality assurance process and help to mitigate human error in real time.
We were able to trade a version of the platform and integrate it with Bravant Industrial Vision solution, and also with OpenVINO we can run the models in real time at the edge. We replicate the assembly cell in our innovation lab, and we use the platform to develop object detection, image classification, and semantic segmentation models to monitor and validate the entire process. The platform helps us train and optimize all these models easier and faster, and we can go to production with that models in a very short time. Compared with the service we used before, this platform saves time in labeling images and training models. Furthermore, our solution now is easy to scale. This platform offers us more tools to train and develop computer vision models. It is an easy-to-use platform, and our client can collaborate with us on image labeling and be aware of the progress after each version update. Ultimately, working with the platform and the Intel's OpenVINO toolkit increased productivity and allowed us at Bravant to focus on software development and the creation of new computer vision application products and solutions.
It's a great use case. I really like that video, and it's been a pleasure working with that team as well. The feedback we've had from that on their use of Getty is phenomenal. The time that they've saved and the collaboration with other skill sets in regards to data scientists, developers, and subject matter experts really helped them build a great, robust system. So congratulations on a great solution, Bravant, and thanks for working with us. It does feel a bit advertisement this week, doesn't it? I do apologise. Now
I'll bring it back.
bring it back to norm, yeah. Ollie. Bring it back to norm, and let's show everybody a little bit of a hack and get some blue tits recorded. So over to you, my friend.
Fantastic. Thank you very much. Hi, everyone. Yeah, I'd like to take you on a little bit of a journey of a project that I started back in March, installing a bird box with a camera in it. That was the start of the project, and as I guess you can probably gather from the various LinkedIn posts and the title of this, the most ridiculously over-engineered bird box, you can guess that it expanded a little bit beyond the initial brief. So anyway, I installed this bird box. And it's a fairly standard one with a It's a box with a camera in it, and it's fairly easy to digest these. You can connect it to any CCTV recording software, for example. It's just outputting a standard RTSP stream that can be consumed by multitude different bits of software. Now that's not the issue. The issue is that actually monitoring this thing is a full-time job. I don't particularly want to be staring at a box with a camera in it all day long, trying to see if a bird arrives. I'm aware of the irony that, in fact, I am staring at a camera in a box just now. It's just a plastic one instead of a wooden one, but never mind. So turning on the motion detection on the CCTV software does record some things here and there, but they're quite prone to false positives. So when you've got lighting changes, when it flicks from infrared to RGB in the top image, it triggers the motion detection, so you get false positives. I don't want to have to sort through all those clips to find out if anything interesting occurred. And the same with the bottom clip, when the bird just pops their head in, again can trigger that and creates a false positive. So obviously, I've been fortunate enough to be working on the Intel Getty platform, so I've had access to this for quite a while. So first thing to do is I want to throw some AI at this, and can I train a model to intelligently understand when the bird is in the box and then use this to either record some clips or do something else with it. So I don't want to throw away any of this data that we've collected from the motion detection. Yes, we've got quite a lot of false positives in there, but we also have some true positives, proper images of when the bird is there that have been correctly recorded. So I upload all these videos to the Intel Getty platform, and I start annotating, drawing bounding boxes around the object to start training the model. And much like Paula's mentioned in some of her videos earlier, that the output of Intel Getty is the OpenVINO model, which is then optimized to run on Intel Silicon. I won't do the hard sell too much now, we're into the fun part. So there I've got my model trained, and then I can replace the standard motion detection model in this CCTV software with my own pipeline using the OpenVINO trained detection model, with the output looking something like this. So we can see that now the bird is quite successfully detected on the left, where it's just after it's laid its eggs. Then on the right you can see it's after it's hatched, and it's detected successfully leaving, and you can see it's working quite nicely. So at this point I'm thinking, job done, excellent, trained my AI model, so I've got this bird box bot. Surely that's the end of the project, right? Well, any of those that know me, that's clearly not the end of the project. So let's see what else we can get out of this, how much further we can push it. So the bird that's actually took up roost in the box is called a blue tit. It's very common here in UK and Europe. And these things, as I say at the top, they are quite tiny, very fast, and really quite agile, as they're the acrobat of the bird world. Quite often you see them perched under branches, pecking, feeding off the underside of leaves for various insects. So I wanted to try and capture some of this agility on film. Now, fortunately, I've got access to this Sony RX100 Mark VII, and it's quite an impressive little bit of kit. Got it just here. And it can record up to 1,000 frames per second. Only 420p, so not the highest resolution, but it's got some fairly nice optics, so you can zoom in quite close and get close to the subject, making up for the lower resolution. So the new objective now is to record some high-speed footage of these birds in flight. But I'm too lazy. I mean, I've been too busy with Intel Getty, of course, to stand there with the trigger button all day and try and capture when these birds fly in and out of the box. So, of course, next thing to do is we want to automate this, so I can spend less time, spend no time, in fact, standing there clicking a button. This is exactly the same process as the first stage, but now I want to train a model for when the bird's outside the box and when it's flying to or from the box itself. Same process, capture a bunch of images. I again use naive motion detection. Don't care if I get a few false positives. I just want to filter down some of the data so it's easier to find which ones need to upload to the platform. And again, trained in a similar manner, just drawing bounding boxes around the object, and within, I think I did this in about a day or two, maybe a weekend, trained this model up, and we've got a fairly successful model detecting the bird as it's flying to and from the box. This time though, I used a USB camera. Just from prior experience, I knew that an IP camera probably wouldn't work in this use case. typically, although you get, say, 25, 30 frames per second coming from an IP camera, so the frame rate's good enough, but there tends to be a reasonable amount of latency on them, particularly if you buy the cheap ones that I've bought, due to the internal processors on them and the cheap Wi-Fi chips they might use. There's various lags that mean that by the time the event has actually happened in the real world, it could be 2 or 3 seconds later by the time that frame is encoded, transmitted, decoded back onto the whatever destination screen that you're viewing it on. So that's the only difference here. I used a USB camera. Luckily, again, quite lucky with a few of these things, I've got access to quite a good amount of hardware. So this is actually a machine vision grade camera from a company called Zymir from a project a long time ago. You could absolutely use the Pi camera for this as well. I just happen to have this one, so why wouldn't I use that? And as Paul was mentioning earlier, you've got the OpenVINO model here, and this is running on a bit of spare kit that I've got, which is an i7 9700K. And that was running at full speed that the camera was capturing video, so this is running at full 30 frames per second. Now what I wanted to do is actually do something with that data. Now you see lots of great examples of these models running with bounding boxes being drawn, like you can see out on the right here. But we need to actually get some action from that data and actually take some action, either get some data insights or actually actuate something, whatever. So what I did was output the data. So I'm running this in Python for the OpenVINO detection model. And then I'm outputting these results to MQTT. And for any IoT buffs out there, probably well aware that this is it's a pub sub message queuing telemetry transport, if I've got the acronym right. This is a communications method that IoT uses. As I said, it's a pub sub method. So you could have multiple clients subscribe to a topic. You can have one a device published to that topic, and everyone subscribed to it will receive that same data. This is actually running on a Raspberry Pi 4. This is actually running most of my house, running things like Node-RED and Home Assistant to grab loads of sensor data from around the house and control the lighting. On the back end of MQTT, I have an InfluxDB database. This is a time series database. It's actually running on quite a crusty old Atom Mini ICX that I've got lying around. Only realised the other day it's about 13 years old, still going strong. The Influx install is only about 5 years old, but the hardware is about 13 years old, and it runs quite happily. Where you find Influx, you usually find Grafana not far behind. This is a great visualization tool for viewing this time series type data. And you can see here that we're getting the detections plotted as a function of time, so you can see how active these birds are over the course of the day. And then you can start to get some really cool insights into this. So this is about 20 days or so towards the end of the project. And obviously you've got some things like the time where they start roosting in the evening and when they get up in the morning. And there's some spikes here early in the morning where you can see indeed that the early bird does indeed get the worm or caterpillar normally. An interesting one here is this is actually absolutely hammering it down with rain this day over lunchtime. And you can see that they decided not to go shopping much over this period. They were hunkered down in the box, or if they did venture out, they didn't come back quite as frequently. Whether it was more difficult to find the insects or not, I don't know, or whether they just didn't want to fly in the particularly heavy rain. And then towards the end, this is actually the last day over that 24-hour period where they started to fledge. So after this, there's no more detections as they all left the nest. There's quite an interesting one here where they disappeared for a couple of hours, obviously fearing the worst, but they did come back, so I assume they just wanted some time away from the kids at that point. So let's go back to the architecture a bit here and have a look. So I've now got loads of time series data coming out, which is quite cool to look at. And then I started to think, well, because I've got this running in Python, there's a million Python libraries for pretty much every function out there, and of course there's a library that helps you integrate with the Twitter API as well. So I thought I'd have a quick play with that. This is where BirdBox bot Twitter came up, and every hour or so it would take the latest video and upload about 10-15 second clip of the latest detections and latest view from within the box. And then every half an hour between that, it would upload a graph as well. So you can see in the bottom right, we've got the Grafana image and also another representation of that data in this kind of heat maps, time series heat map. And then it'd also tag various people and add hashtags to it as well. And occasionally bug my colleague Paula. Apologies if you got disturbed during the night with notifications from Birdbox Bot. So at this point, I'm starting to get a little bit just distracted. Know what else can I plug into it? Plug it in graphs, stats, Twitter, whatever. I want to get back to the main goal here. Let's try and get some high-speed video recorded. So we've got the RX100, and we want to connect this into the pipeline somewhere. So we want to get it connected to MQTT. Again, that's our message queuing and telemetry transport. So this is the thing that powers the backbone of the IoT components. So if you're not familiar with how some of these high-speed videos are triggered, how they're recorded, typically they have an inbuilt buffer, a running buffer of a couple of seconds, and you can either trigger them at the beginning of the sequence or at the end of the sequence. So if you trigger it at the end, it will just record the last couple of seconds to your SD card. Or if you can trigger it at the beginning, much like you would with a standard video recording. Obviously, if you trigger it at the beginning, you have to know when the event is occurring, which is quite difficult. But with the triggering at the end of the sequence, you can do that once the event has occurred. So in order to actually trigger the recording, there's this little button on the back of the camera that I had to press. And going through all my mind how I can actually do that, thinking of how I can use actuators and servos and whatever. It's going to be quite complicated. It's quite a small fiddly button. So I ended up buying an external remote, how to trigger this. It's a bit bigger button, but I don't particularly want any mechanical solutions in this. I want something a bit more reliably. So I want to go for an electronic solution. So of course, to actually do that, I need to go a little bit deeper, which started to get very deep. So I ended up ripping the whole remote apart, hooking it up to the oscilloscope, trying to work out what the protocol was that was being sent over to the camera, so I could try and debug what these messages are, so I could then simulate what these were from like an Arduino or something, so I could then fire off this record signal myself. This was getting really deep, spent several hours trying to debug this, trying to work out what the handshake messages are between the controller and the camera. So took a step back and thought, right, hold on, let's just read the free manual if you're not quite sure what that acronym is. There's other interpretations of that acronym, of course. And it turns out that there is a setting in the camera that enables what's called movie with shutter. Buried deep into the settings somewhere, bizarrely in a display settings for the movie, is a setting on how you actually record the movie, which is I'll leave that comment for another day about why that was buried that deep in. Anyway, you might be asking, how does this help? I've still got to actually press the button on top rather than the camera button on the back. This helps significantly. So many of these cameras that have external triggers have a much easier way of triggering the shutter, the main top button that you're normally pressing. These can be done with a standard 2.5 or 3.5mm jack normally. And this normally is a case of just shorting out two of these connections on the barrel, usually ground and one of the other ones. The two pins normally correspond to autofocus and shutter. So most of these cameras, I'm sure most of you are aware of, have a two-stage trigger. So the first stage sets the autofocus, then you press the second stage to take the actual picture. So all you need to do is short these. Sometimes some cameras let you just short the shutter button. Some you have to short the autofocus and the shutter. Sometimes they have to be in order as well. So there's a little bit of variation, but no, it's quite an easy thing to solve. Just short the connections. And if anyone saw my appearance a couple of years ago on this, I actually had this exact same thing, similar projects, but this exact same board was used to trigger a DSLR, a Nikon D90, which worked exactly in the same way. So here I'm using a ESP8266. If you've not used one of these, highly recommend getting one to have a little play with. Fantastic little devices, really cheap, like under $5. Use them like an Arduino, but they have Wi-Fi on them, which is great. And they're super small, super cheap, and can run off the USB 5 volts as well. So they're really versatile little boards. But having the additional Wi-Fi is what really makes it for me. So here we've got two little chips on the right-hand side. So these are called opto-isolators. They essentially work as digital switches. So all I have to do is turn them on from the ESP side, and then it effectively short circuits the other side of the chip, which basically switches on the pins that are on the connector. So now we've got the whole setup in place. So we've got the Xymea camera watching the bird box. The feed of that is going through the OpenVINO detection model. A bird is detected, message is sent via MQTT, influx is subscribed, ESP8266 is subscribed to that topic as well. As soon as the ESP receives the message, fires off the Sony RX100 camera, and we trigger a recording. So let's little video of it all coming together. So you can see here the camera pointed at the box. There goes the bird, and hopefully saw the detections. And then a signal being sent over MQTT, ESP triggers the camera, and there we go. End of the buffer is recorded to the SD card. And I'll show a slightly different shot with some of the timings. So here I've managed to place the camera outside, and you can see here that the top video is actually recorded from my phone. Most mobile phones these days can do slow motion of around 120 or 240 frames per second. But being that I'm a bit further away, the resolution's quite poor. So you can see here that's the phone footage, and then rough time sequence in the bottom for the images from the USB Xymea camera with the detections. And all this comes together for the money shot, which is this fantastically close-up shot of the bird flying at slow motion, about 1,000 frames per second. I should have put some classical music over this or something to make it a bit more interesting. But this is something that I wouldn't have been able to do. There's no way I could stand this close to the bird box and record manually. Oh, there's some music somewhere. And of course, with all the food going into the bird box, there's obviously something that needs to come out. So they did a great job of keeping the bird box clean. So you can see that was some excrement they were taking out. I think there's one more after this. Oh no, a couple more. It's fascinating to see some of the objects they're bringing back. So we had caterpillar, beetle in this case, and then I think we have a massive grub coming in from the top there. Thank you, Maestro. That's the end of those clips. So super happy with that, but obviously the really important bit is what was the outcome of the nesting pair. So this is a very short time, well, fairly short time lapse of about 3 months compressed into a few seconds. So we had a nesting pair that actually managed to lay 10 eggs. It's fairly average yield. Doing a bit of research on it, and obviously nature can be quite cruel, so just always preparing for the worst to happen at any point. But of these 10 eggs, The number that hatched was actually 10, which was quite a surprise. Because the reason why they have so many is because obviously you expect a certain attrition rate. And of these 10 that hatched, it's quite fun watching the time lapse because it's just this bubbling mass of those 10 that hatched. The ones that fledged were actually all 10, which is quite amazing that they managed to get 100% yield. So that was quite a spectacular result overall. Can't take any credit for that. That was all on them, but it is a fantastic bit of fun project. And that was how you create the most ridiculously over-engineered bird box using only computer vision AI models, Wi-Fi, MQTT, InfluxDB, Grafana, 3 cameras, Twitter APIs, an ESP8266, high-speed video photography, and of course a Raspberry Pi.
Absolutely brilliant. Fantastic. Does anybody have any questions on, possibly, without a doubt, actually, my favorite project of the year so far? If you have any questions, please do drop them in the comments. We are going to have to wrap up. We have overrun by about 10 minutes. I'll let Alex on my team has just been answering some of the questions in regards to Intel Getty and what it supports, and also about our controlled release as well. Please do reach out to myself or my team members if you're interested to know more. We'd love to hear about use cases and uses that you would use with it, and put you on the list to get in contact with you as soon as it's mass publicly available, as we've got a controlled release going at the moment. Oliver, Paula, thank you so much. I've really enjoyed today. Sorry to everybody if it was a little bit too marketing in regards to some of the videos that we've made, but I really like them. I think some of the videos there are great, and we've really built up some great relationships with the use cases on those, with Royal Brompton and Brabant. We've got more coming on the website over the coming weeks as well, so do register your interest and follow the website. Some great stories coming through from that, and of course the coffee beans with Paula, which is another great video. We need to get the bird box on there, Oliver, I think. But thank you. Just a quick bit of feedback for you, Oliver. A really good and nice project. Thank you, Michael.
Thank you very much
for the feedback. And on that, what's happening next with IoT North? So we have actually, this is how, so I got sent this via chat by Evan, and I just want to show you the perfect way on how to watch IoT North on a monthly basis, first Tuesday of every month, which is to have some hot wings and a beer. Oh, he's got a Pepsi Max. I'm pretty sure there'll be a beer on the side, known Evan, and catch up on the show. So that's, that's the recipe for moving forward. However, 1st of November, we have a great show which has been organized by my colleague John Staveley. John, thanks so much for organizing and doing the show last month whilst I was away. Great show. I did catch it, and sorry you had some technical issues. That was on me. So we've got Rob, and who is Vice of Technology Partners at Device Authority, and has 30 years experience across cybersecurity, Internet of Things, SaaS, semiconductors, and software engineering. He's going to be sharing his great insights in IoT and cybersecurity there. So always a hot topic in this space, so do catch that show. And then we will also be doing, we're going to attempt, probably set myself up for failure, but we're going to attempt to do a in-person live streamed show with our sponsors, Newcastle University, who've kindly helping us for the next year and offered us some sponsorship. So thank you to Sarah for helping with that. But we're going to go and catch up in person and do a bit of a Christmas special. So those of you who've seen the shows before, we have a bit of a round table with some previous attendees that have come on the show. We'll talk about what's been happening over the air, what's been the barriers, what we've done to get around them, and just talk IoT, really, and have a bit of a laugh as well. And hopefully the university will allow us alcohol on premises. If not, it'll be a short show and we'll go to the pub. And on that note, thank you very much. Please do follow us on Meetup. Search for IoT North if you don't. We're also on LinkedIn, Twitter. Just search at IoT North U, I think, on Twitter. And thank you again, Oliver, Paula. And on that note, I'll find my outro and say good night.